All right, good afternoon everybody, also from my part, very welcome here. I will explain you about the work, how to investigate, give extra value to our collection. As you've heard from the colleagues, we're really proud that we manage more than 1,500 accessions. And the colleagues are doing an excellent job in distributing that and discovering interesting things in that collection. And some things are really obvious, like the vitamin C, or parthenocarpy, big stones in bananas. But we should realize that this collection is a real treasure of things that are not discovered yet. And one of those things is tolerance towards droughts. Bananas are a crop which use a huge amount of water. To produce them, people use a huge amount of water. And every commercial banana plantation uses precious water to irrigate, to keep up with the production. What you see here is a map of the world of which is calculated where it's suitable to grow bananas without additional water. We now realize that our agriculture is now using already 70% of our water. And we're realizing that water is something really precious to conserve. So growing bananas is something that really consumes a lot of water. And please take a closer look at this map, because the dark green and the light green, very suitable and suitable. This is the places where you can grow bananas without adding extra water. It's quite challenging, right? There's not too many places where you can grow them. So that's why we are looking towards species that use their water in a much more efficient way. This map has been made based on past climate data. So we are now hearing a lot of climate change. How will this change in the future? We don't know. But we need to be sure that we are prepared to do so. You probably all have a plant at your home, and sometimes you forget to water it, and very often it will show signs. You look at it, it looks wilted, right? A banana plant will not do that. It just sprouts standing there, and early signs of drought is not displayed. So how to discover that? It's a challenge, because drought is really complex to do research on. But luckily we have our collection. But as the colleagues has told you this afternoon, it's huge. We have more than 1,500 different varieties. Where to start? This is a challenge for a small research team as ourselves here in Leuven. So we had an idea to create a lab model. Let's create a model to really fastly screen the potential of certain varieties. So we grow them in the lab and we calculate how fast are they growing under ideal conditions and how fast are they growing, or slow they are growing, under mild drought stress conditions. But still, 1,500 is way too much. So we created a subset of 30, let's say, families, and we started doing this, let's say, the last 5 years. We created a subset and we estimated really accurate in our lab model how are they doing with less water and how efficient are they in using water. But of course we realize that this is a lab model, and a lab model is a model and it needs to be validated. So the next step is to apply real drought in pots, and we go to a greenhouse model. And with that we have two things. We can select big families that are tolerant to droughts or really sensitive to droughts. And we can learn how a banana plant responds very early to mild stress conditions, because I said it's really difficult to see that they are stressed, but the consequences are enormously. So once we have that, of course, we have it only for a subset, and we need to go back to our collection and confirm that indeed this family has really potential and discover interesting genes, because this is our end goal. Once we have the genes that are responsible or correlated towards this tolerance, we can think about breeding. And with our things that we measure on plants while they have mild drought stress, we can give advice to farmers, because we can recognize in the field, if you have this banana plant and you don't irrigate, this is what would happen, and we can help them in recognizing those early events and giving advice in irrigation. So our strategy, to summarize, is based here in Leuven, where we have our lab models, from small to bigger, but of course, they stay models that need to be confirmed in the field, where we really confirm what we have seen in the lab. Yes, in the field, it gives makes a big difference. With that amount of water, it gives you a really nice yield compared to another one. So let's spend some time in what is now a lab model. What do we do with that? It's a lab model because we control everything perfectly. They are small plants, and everything is perfectly controlled, how they grow under ideal and under stress conditions. And we developed software to take pictures of them at regular time points. It's really straightforward. It's not expensive. It's just a camera, a blue background. You take a picture, and the software really calculates the area of the plant. And if you do that in time, you can create your growth models. Some of you have seen this in the greenhouse. We can do it also with big plants. We can do also a next step. On the left, you see a tolerant variety, the leaves of them. On the right, a sensitive variety, to exactly the same conditions. So the software does not only calculate the leaf area, but also calculates the damage. So in yellow here, I don't know how visible it is in the back. In yellow, the software calculates this tissue, this leaf is damaged. So we can also calculate the damage that is formed over time, and so we can judge indeed what is the potential of this variety. So this is our growth model. But we want to also understand during early stress really what happens. And then we developed software. You see balances there on your left. And we couple these balances to a laptop. And of course, we place plants of them, and we observe how they grow over several times. And those balances, every 10 seconds, they register the weight. And so you can calculate how much water a plant is losing at a certain time. So you see there's indeed some plants that consume in exactly the same room more water than others, because plants can really control how much water they are transpiring. We human beings have pores to sweat, while plants have holes in their leaves where they can open and close. And of course, like that, if it's open, they lose a lot of water. If it's closed, they lose less water. And so balances are really nice to accurately calculate, but I hear you thinking, how do you apply this in a field? You cannot take a balance to the field, right? So, no, we don't. Plants have pores. Here you see the opening. They can open and close. And if they open, they lose water, like we sweat. If you lose water, you lose heat, so you cool down. So we have an infrared camera that measures the temperature of the leaf. They're nicely blue, and if the pores close, we see this in the field because the leaf heats up. So it's a simple infrared camera from where you can buy in construction too, and you just place the camera on the plant while it's happening. Now it's nice and blue, plant is transpiring, losing a lot of water, and in a moment you will see like it gets a different green color, so it heats up. This is the moment where it closes its stomach, and you can learn a lot from that. So the next step there is, of course, our greenhouse. How does it look like? A greenhouse where fully automatically takes the plants, gives them a place, randomizes, weighs them, and calculates how much water they need. In that way, you can really control the stress, and you take them to a photo booth where they are taken with different sensors and calculated in this way, where you confirm what we have seen in our lab model is really true in a greenhouse. This takes me to the end of my presentation. We are really convinced that we have proven that in our collection there is much difference. There is plants that really have efficient use of water and are much more drought tolerant, and that genetic diversity really helps in the search for drought tolerant bananas. I thank you for your attention, and of course our partners. Thank you.